So today we're going to talk about function notation and evaluating functions. So before we get started, I want you to pause the video here and make sure that you can write down everything in this top box. When you're ready, press play again. So the first thing we're going to do is ask ourselves, what is a function? So a function is a mathematical machine. It takes an input, which can be a number or a variable that you put in, and it creates an output. So on the right here, you kind of see like this machine graphic. You put an input in, usually an x. The function evaluates it, finds our output, and spits it out. So a couple of things to note is that each input can only have one output, but two different inputs can have the same one. So if I put a 3 in and I get a 4 out, I'm not going to ever put a 3 in and get a different number out. That won't work. It'll always be a 4. However, if I say put a 9 in, I can also get a 4 out, and that's okay. And the biggest or the best comparison that we can make when remembering whether a function or an input can have one output or not is what we like to talk about as the birthday function, or it's a birthday example. So what I mean by that is you and your neighbor may have the same birthday, i.e. you and your neighbor, the two inputs, have the same output, but you yourself will never have two different birthdays. So you, the one input, will never have two different birthday outputs. So we're going to jump into function notation and talk about what a function is versus an equation. They're very, very similar. They're just written a little bit differently. So say I have an equation y equals 2x plus 4. I can take this equation and I can write it in function notation. So function notation we write as f parentheses x, and this f parentheses x is read f of x. So f of x, or f parentheses x, is read f of x. That's how we say it. And then everything else stays exactly the same. So if I wanted to write this equation in function notation, f of x would change, or y would change to f of x, and then the 2x plus 4 would stay exactly the same. So f of x equals 2x plus 4. You can also have different variables when you're writing your function. So like f is the name of our function, but maybe we'll have a function named g. So I could write it g of x equals 2x plus 4. So these numbers, the number outside the parentheses can change. So f can change to g, it can be h, and could be any different number. Also, the x can change to different numbers, and we'll talk about that more in a second. But if this x changes, then the x in the actual equation part should change as well. And then one last note and reminder is that basically f of x and y are pretty much interchangeable. They have almost the same exact meaning. So now we're going to jump into evaluating functions. The first example says, given f of x equals 3x minus 2, find f of negative 4. So when we see f in parentheses, it doesn't mean like f times negative 4 in this case. It means f of negative 4. It means that we're evaluating the function f at negative 4. So that means that we're going to take negative 4 and we're going to substitute it into the function where x is. And then we're going to simplify. So f of negative 4 equals, my function is 3x minus 2. So I'm going to copy that down, except for instead of x, I'm going to substitute in negative 4. So this is going to 3 times x, so it's going to be 3 times negative 4 minus 2. So 3x turns into 3 times negative 4 since we're substituting this number in wherever we see an x. And then now we're going to use order of operations to simplify. So f of negative 4 equals 3 times negative 4 equals negative 12 minus 2. That comes down. And then last thing, f of negative 4 equals negative 12 minus 2 is negative 14. So f of negative 4 is negative 14. The next example says, given that g of x, so now we have a different function name, g of x equals negative 4 times x plus 2 in parentheses, find g of 1. So same idea, if we're finding g of 1, that 1 is going to get substituted into the function where x is, where our variable is. So g of 1 is going to be equal to, I'm going to rewrite the function almost exactly the same. So negative 4 times x plus 2, but instead of x, I'm going to replace it with 1. So times 1 plus 2. And then we need to use order of operations to simplify. So I want to simplify what's inside the parentheses first. So g of 1 equals, inside the parentheses, 1 plus 2 turns into 3. So this turns into 4 times 3. And then g of 1 equals negative 4 times 3 is negative 12. So g of 1 equals negative 12. And then the last example, example 3, looks a little bit different now. It says h of z, so h parentheses z, h of z equals z squared minus 4z plus 9. And we need to find h of 3. So now because the function is h of z instead of x, we're going to substitute in this negative 3 wherever we see a z. So, and now because there's multiple z's throughout, we're going to have to substitute this negative 3 in multiple times throughout the function. So h of z turns into h of negative 3, because that's what we're finding and evaluating. Z squared means that I have to take negative 3 and square it. So it's also important that that negative goes inside the parentheses too. And then minus 4z, so minus 4 times negative 3, and then the plus 9 comes down. That doesn't change because there's no z attached to it. So h of negative 3 equals negative 3 times negative 3 squared means negative 3 times negative 3. So the number multiplied by itself twice. That's what an exponent is. So this negative 3 to the second power means negative 3 times itself. And then minus 4 times negative 3. So that's like minus 4 times negative 3 is negative 12. So we're going to have a double negative there. We're going to have to switch it. And then bring down the plus 9. And then h of negative 3 equals negative 3 times negative 3 is positive 9. And I don't care if you get comfortable enough with squaring numbers and you don't write out this second step. Just know if you square a negative number, so negative 3 times negative 3, that equals positive 9. And negative times a negative is a positive. And then minus negative 12 turns into plus 12. And then plus 9 comes down. H of negative 3 equals, now we just have addition, so we're going to add from left to right. So 9 plus 12 is 21. Plus 9, and then last thing to do is add the 21 and 9. So h of negative 3 equals 21 plus 9 is 30. So h of negative 3 is 30.